All right, let's dive in. We're going back to the classroom today, dusting off those high school physics textbooks.
Back to the basics.
Well, kind of. We're using your St. Andrews RC Secondary School revision guide to unpack some of the fundamentals.
Oh, interesting.
Yeah, energy, forces, all that good stuff.
Yeah.
We'll see how those concepts play out in the real world, like why sandpaper is so rough or how race cars can go so fast. I think this will be fun.
It always amazes me how these basic physics ideas, they're everywhere. We just don't always see them.
Yeah, absolutely.
Yeah.
So let's start with energy. Your notes mention a bunch of different types: light, heat, sound, electrical.
Mm-hmm.
And then there's this kind of mysterious duo, potential, and kinetic energy.
Yeah.
What's the deal with those?
Well, you can almost think of energy as this, like a master of disguise, constantly changing forms.
Oh, that's a good way to put it.
It never really vanishes, it just transforms. And potential energy, it's like energy in waiting, ready to spring into action. Like think of a coiled spring or a book balanced on a high shelf. That's stored energy based on like position or state. Kinetic energy, that's the energy of motion, things actually moving.
So it's like potential is just waiting for its chance to become kinetic, right?
You got it. The book falls off the shelf, boom, potential turns into kinetic.
Makes sense. It makes you think about, where does the energy actually go when we use something like a battery?
Ah, great question. So a battery, it's storing chemical potential energy, then that converts into electrical energy.
To power, like our phones and stuff.
Exactly. But here's the thing. No energy transformation is perfect.
Oh, right.
Some energy always gets lost as heat. That's why your phone gets warm after using it for a while.
I noticed that.
It all ties back to this idea of, useful energy versus wasted energy.
Okay.
Your notes have that light bulb example.
Right. The light bulb, we want it for light, but it also produces heat.
Exactly. And in that case, we consider the heat a waste product, even though it's still energy.
It's kind of like when I try to bake.
Yeah.
I might get a delicious cake, but the kitchen ends up like a sauna.
Perfect analogy. It shows how these energy transformations can have, unintended consequences.
Yeah, for sure.
It makes you think about our energy choices, too. We talk about renewable versus non-renewable sources a lot, but...
It's more complicated than that.
Right. It's not just black and white.
You can't just keep burning fossil fuels, though, right? They'll run out eventually.
Absolutely. Plus, burning them releases all those nasty greenhouse gases. Not good for the environment.
Yeah, definitely. But then even with renewable sources, there are trade-offs.
You said it. Wind power, for example, needs so much land, those giant turbines.
Right, and they can mess with birds, right? Like migrations and stuff.
Unfortunately, yeah. Solar power is fantastic, but it's very dependent on the weather. No sun, no power.
Oh, good point. And then there's hydroelectric. Uses dams to harness the energy of water.
Powerful, but can disrupt ecosystems too, building those dams.
Yeah, big impact. And then nuclear power, it's really efficient, but
then there's the radioactive waste to deal with.
it's like a constant balancing act, trying to figure out the best energy source, weighing all the pros and cons.
Isn't it? What's interesting is that wind-up car example in your notes, it's actually a good metaphor for this whole energy situation.
Now, really?
Winding up the car, it takes that initial effort, just like investing in renewable energy infrastructure.
Putting in the work up front.
Exactly. But once you do,
Yeah.
you get clean, sustainable kinetic energy the car moves. And with renewables, clean energy for years to come.
I like that. It shows that it's worth it to make those initial investments, even if it's tough at first.
Definitely. It's not always easy, but understanding these complexities, it helps us make informed choices about our energy future.
For sure, for sure. So we talked about kinetic energy, but your notes also go into projectiles, things that move both vertically and horizontally.
Ah, yes, projectiles. Fascinating how those combined movements create those curved paths.
Like throwing a ball.
Exactly. Or like launching something from one of those, projectile launchers, like in your notes.
Yeah, they talk about pulling back the launcher to store energy in the spring.
Elastic potential energy.
Right, and then releasing it, boom, turns into kinetic energy and the projectile goes flying.
They even did an experiment, changing the launch angle and seeing how far the projectile went, right?
Yeah. They found that a steeper angle made it go farther.
Classic experiment. But think about what's really happening there.
Well, the steeper angle, it's like storing more potential energy in the spring. Right?
Exactly. More potential energy means more kinetic energy when it's released, sends the projectile higher and farther.
Like a pendulum. You lift it higher, it swings faster and further.
Precisely. It's all about that conversion from potential to kinetic energy.
Hmm.
Now, speaking of forces, Your notes define a force as any push or pull that can change an object's shape, speed, or direction.
Right. And I love how they use the tug-of-war example to show balanced and unbalanced
Oh,
forces.
that's a good one. Very visual.
You've got equal forces on each side, no one moves,
Yeah.
balanced. But if one side pulls harder,
Unbalanced forces, they start moving in that direction.
such a simple way to show how forces work.
It really is. And speaking of forces, we can't forget the big one, gravity.
Oh, yeah. The celebrity of the force world, holding everything together.
It makes you wonder what would happen if gravity suddenly took a break? Would we all just float away?
That's a good question. I'd probably bump my head a lot floating around.
That's for sure. But seriously, if gravity vanished, the universe as we know it would just poof, gone. Planets wouldn't orbit stars. Stars would just fly apart.
Wow, that's crazy to think about.
It really is. It shows how crucial gravity is. And it also brings up something people often misunderstand, the difference between mass and weight.
Oh, right. Your notes talk about that too.
Mass is how much stuff is in an object.
Like all the atoms and molecules and everything.
Exactly. But weight, that's the force of gravity acting on that mass. Your notes even have that formula. Weight equals 10 times the mass.
So if my mass is, let's say, 60 kilograms.
Your weight on Earth would be 600 newtons. Important to remember, weight is a force measured in newtons.
Not kilograms.
Right. Your mass stays the same, but your weight would change if you were on a different planet with different gravity.
That's interesting. So it's like mass is what you are, and weight is how heavy you feel because of gravity.
You got it. It's amazing how these seemingly simple concepts, energy, forces, even friction.
They're like the building blocks of everything.
They are. It's like having this, this backstage pass to understanding how everything works.
Absolutely. Speaking of forces that affect how things move, there's friction. Always seems to be working against us.
Yes, friction, like when you're trying to push something heavy across a rough floor.
Yeah, your notes mention sandpaper, how rough surfaces create more friction.
The rougher the surface, the more it grips, the harder it is to move things.
Makes sense. So it's like those tiny bumps and grooves are catching on each other.
Exactly. It's all about those microscopic interactions between the surfaces.
And we're always messing with friction, aren't we? Sometimes we want more, sometimes less.
All the time. Think about car brakes. They use friction to slow down the car. But then friction can also be a pain, like when it wears down a machinery.
Yeah, when you're trying to walk on ice.
Oh, yeah, icy surfaces, very low friction.
Slippery. That's why we put sand or salt down, to increase friction.
Exactly. It's like we're constantly trying to outsmart friction, figuring out how to control it.
Yeah, it's like a constant battle. Sometimes we want things to slide. Sometimes we need a good grip.
Right. And then there's air resistance. That's a type of friction, too,
Oh, right. Through the air.
It can really slow things down, especially in transportation and sports.
Like those super fast race cars. They have that sleek shape, right?
Yeah. Streamlining, that's what it's called, reduces air resistance.
So the cyclists, too, with their tight suits and helmets.
Exactly. Minimizing drag to maximize speed. It's pretty amazing how just changing the shape of something can make such a big difference in how it moves.
It is. So it's like we're learning from nature, looking at how birds and fish are shaped.
They've evolved to be streamlined over millions of years, moving through their environments with minimal resistance.
That's cool. It's like all these physics concepts, they're not just separate ideas. They all connect and influence each other.
They really do. And the more we understand these basic principles, the better we can solve problems and invent new things.
Oh, totally. Like designing cars that use less fuel or coming up with new materials that have different levels of friction, all based on physics.
It's like having this secret code book for the universe, figuring out how it all works.
Going through these notes, though, I realized how much I've forgotten since high school. It's kind of embarrassing.
Don't worry, it happens to everyone. Physics can seem overwhelming, but once you break it down, it's not so bad.
It's like those domino chain reactions. You just need that one push.
Exactly. Cause and effect, one thing leads to another. And the coolest thing about science, it's always changing, new discoveries all the time.
Yeah, that's what keeps it interesting.
So what are some of the big mysteries in physics that you'd like to know more about?
Oh, so many. Like, what's the deal with dark matter and dark energy? They're supposed to be everywhere, but we can't even see them.
Right. We know they exist because of their effects on gravity, but we have no idea what they're made of. Huge mystery.
It's like we're missing most of the pieces of the universe puzzle.
That's a good way to put it. And then there's the whole quantum mechanics versus general relativity thing. Two awesome theories, but they don't quite fit together.
Like trying to force square pegs into round holes.
You got it. Trying to combine those two, that's a major challenge for physicists. Who knows? Maybe you'll be the one to figure it out.
I don't know about that. But you mentioned gravity earlier, this powerful force that shapes the universe.
Hmm.
What would happen if it just, poof, disappeared?
Ooh, that's a good one. If gravity vanished, everything would change. Planets wouldn't orbit stars anymore. They'd just fly off in straight lines.
Like a cosmic breakup?
Stars would lose their shape and scatter. And we'd be floating off into space, too, along with everything else.
It's kind of scary to think about.
It does make you realize how dependent we are on gravity, this invisible force that keeps us grounded.
Yeah, I guess we take it for granted. It's like this big cosmic safety net we don't even notice most of the time.
It really does make you appreciate the interconnectedness of everything in the universe. And it shows the power of physics, not just explaining how things work, but also why they work that way.
It's like learning to read the language of the universe,
Yeah,
understanding the rules of the game.
exactly. And once you understand those rules, you start seeing the world differently. It's pretty amazing.
Doing this deep dive, it's made me curious about things again. I'm noticing physics everywhere I look.
I love that. That's what it's all about. Understanding the basic principles and then seeing how they play out in the real world makes you appreciate the beauty and complexity of everything around us.
It's like the world is this giant playground of forces and energy, and we're just starting to figure out how to play.
And who knows what other amazing discoveries are waiting for us as we keep exploring.
Makes you wonder what else is out there, right? Like what other crazy forces and energies are we going to discover?
Who knows? That's what makes it so exciting. There's always more to learn, especially in physics.
Yeah, always new stuff popping up, changing how we see the universe.
Exactly. It's a never-ending adventure.
This deep dive has been pretty wild, going back to those basics. Energy, forces, friction.
It's amazing how those simple ideas, they explain so much.
I feel like we've only scratched the surface, though. There's so much more to explore.
Oh, definitely. But that's the beauty of it. There's always another layer, another mystery to unravel.
It's like physics is this giant, cosmic detective novel, and we're trying to put all the clues together.
I like that analogy. So before we finish up, any last thoughts for our listener, something to ponder as they continue their own physics journey?
Yeah, give us something to think about.
I would say never lose that sense of wonder. The universe is full of incredible things, from tiny particles to massive galaxies.
It's mind-blowing when you really stop and think about it.
Exactly. So stay curious, keep asking those what-if questions, and never stop exploring. You might just stumble upon the next big discovery.
Love it. Great advice. And to our listener, we hope this deep dive has inspired you to look at the world with fresh eyes, see the physics all around you.
It's everywhere once you start noticing it.
Keep asking questions, keep exploring, and who knows, maybe you'll be the one to solve those big cosmic mysteries.
The universe is waiting.
That's it for this deep dive. Thanks for joining us.